Hello and welcome to another fun-filled adventure in math with Mr. Sims. Today we're going to be talking about the segment addition postulate, which is really just kind of the addition postulate. You're actually going to use the same principle whenever you're doing angles as well. But today we're going to focus on particularly segments because I think it's a lot easier to see in segments than it is to see in other like with the angular addition. I think it's a lot harder to see. So let's go ahead and start. Let's just do orange. Orange sounds like a fun one today. So let's go ahead. I'm going to start off very simply. I'm going to assume you don't know anything about this concept and very quickly progress to these big mama jamas down here. All right, so once again, this is meant to help you in case you are struggling significantly. All right, so let's look at this one here. So this is the most simple problem basically that you can have. Essentially what you have is you have this full distance here is 10, and then it says this distance from K to J is 5, and they want to know what is the distance from J to I. So basically what I have here is I have the whole 10, and that whole is really made up of these two pieces, this piece and this piece. Well, we know what this piece is, 5. So I can say my 10 is equal to this 5 plus whatever this is. I'm going to call this x plus x. So what I have here is I have a very simple equation now that I can solve for x. And you can think of this like a puzzle. Basically, I'm saying I have this big piece. I know I have this small piece. I want to know what this is. And so you do that by subtracting 5 from both sides. And I get x is equal to 5. And that's my answer, okay? X equals 5. All right, so that's a pretty simple problem. Hopefully that made sense to you. Here's another example of the same exact thing. You have the whole is 13. And according to this postulate, it's basically saying the whole is the sum of all the parts. In other words, it's this part plus this part. So this 8 plus whatever this is. Let's call this x. 8 plus x. So using our algebra skills, right? If I subtract 8 from both sides, I get 13 minus 8, which is 5, is equal to x, okay? And that basically right there is the addition postulate, okay, in action. Now, this one gets a little bit harder, but it's really, like I said, just a puzzle, right? Once again, you have the whole. So I'm going to write my whole here is equal to my sum of my pieces. Now, the problem with this one, though, is they didn't give us all the nice pieces that we want. Notice that we are missing this entire piece right here from E to D. We know the piece from G to E, and we know this piece from F to E. But we're missing this piece from E to D. And they want us to find FD. They want us to find this full amount right here. Okay? So this is the amount that they want us to find. I'm going to call this amount X. Why not? It feels right. All right. So that amount X is what they want us to find. Now, I started writing that 20, but really it didn't actually make that much sense in this particular application because, well, actually it does in a way, but let's go ahead and start first of all with what we know. We want to find this amount right here, this ED, because in order to find X, I need to add this 5 to whatever this amount is. Well, now I need to find this amount in order to do that. So I'm just looking at the pieces I have here, and I just start thinking, okay, well, what if I start taking away certain pieces or adding together certain pieces, right? So if I took 12 and I subtracted from it 5, I'm going to get this amount here. Now, does that help me, though, to accomplish the task that I wanted? Not really, because I'm looking for this amount right here, and that doesn't really lead me anywhere. So instead, I'm going to look at this amount. I have 20 here for the full thing. And if I take away 12 from it, well, then I'm going to get this amount right here, which was the amount that I was looking for. So I'm going to take that 20, and I'm going to subtract from it 12. And that right there is going to be that distance, ED. Okay? The distance from E to D is 20 minus 12, which ends up being 8. So I now know that this distance here is 8. And if I want to see if I'm right, if I add this 12 and this 8 together, it should equal the 20, because once again, the whole is the sum of the parts. Or the whole, if I add all the pieces that make up that whole together, it should equal that whole. Alright, so now I know that this is 8, so I'm going to put that 8 there. So you'll notice I have a 5 here, and 8 here. That gives me this total amount. So to find, 8 was ED, by the way. So to find FD, which is the amount they want me to find, right? I said that FD was just going to be X. To make that easier for myself, I'm just going to call it X, so it's just one letter I have to write. X is equal to 5 plus 8. Now X is really F to D, that whole distance, right? But X is equal to 5 plus 8, which ends up equaling 13. So X equals 13. So FD, then, that FD is equal to 13. Once again, I could have just written it. I could, instead of writing X, I could have written FD, right? But I just like writing one single letter. I think it makes it easier to see, personally speaking. All right, let's go ahead and do this one. Once again, we have another thing where we have, they did not give us our whole this time. And sometimes they won't. And so what you have to do is you have to think about it and say, okay, well, what are the pieces I have, and how can I solve for other pieces? And sometimes the best thing to do is just start seeing what pieces I can get. So if I look at this piece here is 9, right? And I notice that this piece here is 1. In other words, this total distance, all the way from here to here, is 9. And so if this amounts 1, then that tells me that this amount is 8. Once again, I just did that in my head, but 8 plus 1 has to equal 9. In other words, I took 9 and I subtracted from it 1 to figure out what was this amount here. And that told me it was 8. And once again, when I take 8 and I add 1, it should equal 9. And sure enough, it does. All right? So I'm going to erase this line here because it's not necessary. And now that I know that's 8, I can continue. I now know that this is 8. This is 1. And actually, they want H to E. So I'm actually done. If I wanted to, I could figure out this amount, right? I take 13, I subtract 1 from it, and I get 12, right? So I could find that amount. But here's the cool thing. I didn't even need that amount because they wanted HE, which was this total distance from here all the way to here. And I now have this distance from H to F, which is 13. And I have this distance, 8. Well, if I take that distance, and then I take this distance, and I put these two distances together, if I add 13 plus 8, that gives me the total distance all the way from H to E. All right? So that distance ends up equaling, oh, sorry, I guess I could have left that actually. Let me just leave that. I like the way that looked. So HE. And that distance ends up being 21. So 21 is equal to HE. All right? All right, let's continue. All right, so far, none of these problems have been terribly difficult. I'm talking you through them just in case you're really struggling with visualizing this, okay? So, once again, they're nice to us, and they give us pictures, which is super nice. I mean, they don't have to give us pictures. In fact, later on they won't. But let's go ahead and look at this one, 12. So 12 is my whole now, right? Now, remember that whole has to equal the sum of all the pieces. In other words, it's going to be JI plus IH, right, plus HG. If I take all those distances and I put them all together, it should equal 12, right? Well, the good news is they've given us a couple of these pieces. I'm just going to erase them and substitute them. Essentially, that's what I'm doing, right? 8, and this distance JI is 1. Once again, I'm just showing you these are just different ways to tackle these problems. Now, the piece I'm missing, though, is this. But now I can solve for IH. If I know all this other stuff, I can solve for this one. So I'm going to subtract 1 from both sides, right? So I get 11 is equal to IH, right, which is the distance, plus 8. Don't think that's I times H, because that would not make sense in this case. Subtract 8 from both sides, right? And I get 3 is equal to IH. Now, if I put in the 3 here, it should make sense. 1 plus 3 plus 8 is 12, which is what I have. The whole is the sum of the parts. And so it does make sense. There we go. I got it right. Feels good. Winner, winner, chicken dinner. All right, here we go. Let's go to the next one. Find LK. Now, this one freaks you out, and I understand why it does. What you see here is now they've moved away from nice numbers to algebraic expression, right? And when moving to algebraic expressions, it adds another level of complexity. However, it's still the same process. Notice you have a whole, and notice you have the parts. And I can take that whole, and it's equal to the sum of all those parts. In other words, it's equal to 8 plus 2x plus 20, right? Plus x plus 10. And I suggest when you add these together, because later on you're going to be doing subtraction and stuff, make sure that you do it in parentheses. You can always get rid of the parentheses later, right? In this case, you didn't need those parentheses, but that would change if you were doing a problem where there was subtraction, because you would need to remember to distribute in a subtraction sign if there was one, right? So x plus 22 is equal to all of this, right? Now what I'm going to do is I'm going to combine like terms here. So I now have 3x. I'm not going to skip any steps here. I'm literally going to go slowly so I don't lose any of you, okay? And this is x plus 22. Now I'm going to subtract x from both sides, right? To get rid of this x on this side, which leaves me with 2x plus 8 plus 20 plus 10 is equal to 22. And I'm almost done now, because what I need to do now is just combine these terms here, which is 2x plus 38, right, is equal to 22. When I subtract 38 from both sides, I get what? 16? Is that right? Yep, 16. Negative 16, actually. Negative 16 is equal to 2x. I divide by 2, and I get x is equal to negative 8. Alright, so x is equal to negative 8. So now that the x is equal to negative 8, that's not my answer. You can't have a negative distance. You could have negative displacement, but not a negative distance, all right? And that's something completely different. But here's negative 8 is equal to x, right? And because negative 8 is equal to x, what I'm going to do is I'm going to take and I'm going to place negative 8 in, because they want me to find LK. It tells me here that LK is x plus 10. So I'm going to take my x plus 10 for LK, right? Is equal to LK. And I'm going to plug in negative 8 instead of that x. So I have negative 8 plus 10 is equal to LK. And that gives me, of course, 2 is equal to LK, right? And if I actually wanted to see if I got all these right, what I could do is I could plug in negative 8 for all these x's and this x here, and see if all the parts equal the whole, okay? All right, let's continue further in, deeper into the math. Alright, so this one here, now these freak you guys out, and I understand why it freaks you out, but let's look at is it a logical thing for it to freak you out? And the answer is not really. If the rest of that has been pretty simple for you, then there's no really reason for these to be particularly problematic. It's just a matter of not freaking out, doing what you know, and seeing what you get. So the first thing I'm going to do is I realized while I was doing those that it was very helpful to have a picture. So I'm going to start by drawing a picture. And when I do that, I'm going to label my picture A, B, C, and finally D. And then they're going to give me some lengths, and I want to put those in the appropriate spots, all right? It doesn't matter if I put them above or below, but I need to make sure I understand what areas belong to what. AC is equal to 17. In other words, this distance all the way from here to here is 17. This distance B to D is all the way from here to here, and it is equal to x plus 4. Okay? And this distance, where? CD is equal to x minus 3. And finally, AB is equal to 2x minus 4. Now, if you're looking at this problem, you're struggling to find the hole, and that's correct. It's not easy to find the hole in this problem. This problem requires a little bit of manipulation. All right, and here's what I have to say about that. When you come up with a problem like this, there's basically like 3 archetypes that you have to look at, all right? And this archetype, what I want you to do is think about it. If the whole is the sum of the parts, right, then what I need to do, first of all, is find one whole. I need to define the whole. So I'm going to start by finding out some pieces I can put together to make one whole. And I'm going to start with this AB here. So I'm just going to take 2x minus 4, right? In fact, let me move that just a little bit higher. So I have 2x minus 4. And I'm going to add to this distance the amount that I still need. If this is the 2x minus 4, right? I need this other distance here that's all the way from B to D, because 2x minus 4 was just from A to B. So now I have x, so I need to add to that x plus 4, right? All right. And what I've done now, on that one side of the equation, I have one entire whole length of the segment. Now what I need to do again, and this is just something to help you out, really the best way is to be able to visualize and understand how to put all these pieces together, but this is just something to help you out. When you come up with a problem like this, essentially I've defined the line with these 2 equations here. I put these 2 equations to make one whole line segment from A to D. I've defined it one time using this and using this. I cannot use those again, so what I'm going to do, I'm just going to take a purple here and just, you know what, I'm going to take blue so we don't get confused. I'll take blue and we're going to cancel these out because I can't use those again. Otherwise I'll end up messing it up. Alright, so what I'm going to do now is use, stuff will cancel out and I won't be able to find what I'm looking for, okay? So I need to redefine that same length again, because remember, we're saying it's equal to this, right? So I need to find the same length from A to D using different parts. So notice that this part from A to C is 17. So I can take that 17 and I can add to it this distance from C to D. And once again, that is going to give me my entire length. So I now have 2x minus 4 plus x plus 4 is equal to 17 plus x minus 3. Okay? And all I did was got rid of the parentheses because it was just addition. I didn't need to distribute anything in. So now I'm just going to combine like terms and once again solve for x, right? So I combine the x's. I get 3x minus 4 plus 4, which obviously are going to cancel out, right? And then I have 17 plus x minus 3, which is really just x plus 17 minus 3, which I could combine too. So that's going to be x plus 14, right? And this one over here is going to be 3x. So 3x is equal to x plus 14 because these cancel out, minus 4 and positive 4. So now I'm going to subtract x from both sides, right? When I do that, I should get 2x is equal to 14. I divide by 2, and I get x is equal to 7. Now, obviously, 7 is not my answer. Just don't forget, they want me to find BD. So actually, what they want me to find is this length BD. The only reason we crossed it out was so we didn't use it again accidentally on the other side of the equation. So now that I know that BD is the amount I'm looking for, and I know what x is, I'm just going to put the amount BD. They said that BD, right, was equal to x plus 4. So now I'm just going to plug in for x, the 7. So I have 7 plus 4, which is equal to 11. So in other words, BD is equal to 11. Bada bing, bada boom. All right, let's go ahead and move on. So that's one archetype you see. Once again, they didn't give you the whole. You had to basically make parts equal the whole, right, on one side, and then different parts equal that same whole on the other side, right? So, okay, let's go ahead and move on to this one. So BC is equal to x plus 15. AB is equal to x plus 6, and AD is equal to 19 plus x. And CD is equal to 3. Find AB. Okay, so once again, I'm going to start with my beautiful, wonderful line, right? I'm going to make my dots A, B, C, and D, right? Always draw yourself a picture, right? If you don't draw the picture, then you are relying on someone else's generosity of pictures to get you through, and that is a bad idea. So here we go. So let's start with BC. It says BC is equal to x plus 15. That's beautiful. AB is equal to x plus 6. Also beautiful. I like that. AD, the entire amount, they said, is equal to 19 plus x. I'm going to put that here, 19 plus x, and that distance goes all the way to here, and it goes all the way to here. And finally, CD is equal to 3. And this is actually one of the most straightforward problems, because this is literally, it follows the actual wording of the addition postulate, which says the whole, which is A to D, they give us the whole, right, is the sum of its parts. So in other words, it's this distance from A to B plus this distance from B to C plus this distance from C to D. So I'm just going to go ahead and put this in, x plus 6, right, plus x plus 15, right, plus 3. I don't need to put parentheses around that 3 because, oh, it's just a 3, right? All right, here we go. So now I have 19 plus x is equal to, all I'm going to do is get rid of that parentheses and start simplifying some stuff, right? Once again, because it's not a negative sign, I don't have to distribute anything in. Makes me a happy camper. I have 19 plus x is equal to, I'm going to start combining these x's. That's 2x, right? Plus 6 plus 15 plus 3. And if you think I'm going slow on this, you're right, I am. I'm going slow on purpose to make sure I don't lose anyone. So this is 2x. I'm making sure I only do one step at a time between writing these different iterations. Not iterations, but different steps, right? Plus 6 plus 15 plus 3 is going to be 21 plus 3, which is 24, right? So I have 19 plus x is equal to 2x plus 24. I subtract x, and I get 19 is equal to x plus 24. I'm going to subtract 24 from both sides. X is equal to negative 5. Okay. Now that I know that x is equal to negative 5, that's not my answer, but it does help me to find my answer. They want to know the distance AB. So they're looking for this distance here, which I know AB is equal to, that distance is equal to x plus 6. And because I know it's x plus 6, since I know what x is now, I can solve for what the actual distance is. Negative 5 plus 6, which is 1. And obviously you can see that these distances here and everything, guys, they're like, when they give them to you in diagram forms and stuff like that, they're not going to make them to scale most times, okay? Because they want you to actually have to think. So AB is equal to 1. All right, let's do the last archetype, okay? So the last archetype problem is this, where I find AD if AD is equal to x plus 29. Woo! Okay, so once again, I'll start making my line. Go ahead and make my dots. 1, 2, 3, and 4, right? And I'm going to label those dots as well. Here we go. So we have A and B and C and D, okay? And it says that AD is x plus 29. So once again, they give me the whole, which is super nice of them. Look at them being just such team players. X plus 29, right? And we also have AC. AC is this distance from here to here. right? And it doesn't matter if you draw them on top or bottom. I'm choosing to draw them wherever it's not going to be confusing for me, okay? So wherever I have enough room to make it not confusing is where I'm drawing them. So AC is equal to 18. BC, this distance here, is equal to x plus 10, right? And finally, BD, which is the total distance from here to here, is equal to x plus 17. This problem is probably the hardest archetype of problem, all right? Because you have to use some subtraction here, okay? So let's go ahead and start off. The nice thing is they give us one whole, right? So I'm going to take my whole and I'm going to put it on one side of the equation. And once again, I'm trying to redefine this distance from A to D. I'm trying to redefine it again using not the x plus 29, okay? So what I need to do now is I need to use the other pieces that I have. So I'm going to start with this 18 here, all right? I'm going to see where it leads me. So I start with the 18, and then I want this distance here, right? Well, this x plus 17 includes this distance here. So you know what? I'm going to add to it the x plus 17. Now the problem is, what I've done now is I have added a certain segment 2 times. The 18 was all the way from here to here, and so it included this segment right here, right? And the x plus 17 was from here to here, so it also included this segment here. In other words, segment BC has been included 2 times, once here and twice here, okay? So what I need to do is, because I've included it twice by adding these two together, I need to one time subtract the x plus 10. So I'm going to now subtract x plus 10. And this is where I was telling you it's very handy, and make sure you do in parentheses your substitution, right? So I have x plus 10, which is that distance there. Now, if I look at this, I'm saying, okay, if I take this distance 18, and then I add this distance x plus 17, and then I take away one of these distances here, since it's overlapping here twice, right? If I take away one of those distances, that right there is going to give me this distance from A to D. I'm going to redefine it using different terms than the first time I defined it with the x plus 29. So it looks right to me, so I'm going to go ahead and take now and solve for these things. And I start by, I can get rid of this first parentheses, but this parenthesis I cannot get rid of. I need to distribute this in to both of these because it's a negative sign. So I now have negative x minus 10. All right, super important that you do that right. So I now have x plus 29 is equal to 18 plus x plus 17 minus x. Oh, I didn't actually simplify anything there. So let me go ahead and simplify this x minus x. When those will cancel out, so I end up with 18 plus 17 minus 10. So x plus 29 is equal to 18 plus 17 minus 10, which added together ends up giving me, what's that, 36 minus 10, which is, oh, it's not 36, sorry. It's 35 minus 10, which is 25, is equal to x plus 29. Subtract 29 from both sides, and I get that x is equal to negative 4. Now that x equals negative 4 is super duper helpful, because now I can take that x equals negative 4 and find what they want. They want me to find AD. So as you remember, AD is equal to x plus 29. So x plus 29 is equal to the distance AD, right? So what I'm going to do is I'm just going to plug in for x the negative 4, which I have. So negative 4 plus 29 is equal to AD, which is equal to 25. So 25 is equal to AD. And that is my final answer. So all right, so let's look at these three archetypes. Remember this one here, they gave you the pieces, right? They didn't give you the whole, and what you had to do was define the distance from A to D with one set of parts, and then redefine it again with another set of parts and just set them equal to each other, and then solve for x and continue. This one here, they gave you the whole, and they gave you all of the parts neatly lined up, and all you had to do was set this whole equal to the sum of all its parts, right? And this one here, they gave you the whole, which was nice, but then they didn't give you the nice neat pieces. So what we had to do was take one of these pieces and subtract from it this small portion here so that we weren't overlapping the same amount 2 times. All right, so those are basically the 3 archetypes that I've seen lately on those. Anyway, hopefully that helps you out. Once again, this is a video to help you. My suggestion for you whenever you watch my videos is make sure that you have a piece of paper and pen handy and that you're actually working through the problems. In other words, you can pause, try the problem yourself, then turn on the video and see if you got it right. And if you didn't get it right, well, you know, you can try it again afterwards. The nice thing about a video is you're not bothering me at all, and you never bother me, just so you know. But with a video, I know a lot of people feel really comfortable because they can watch it and watch it and watch it until they finally get it, all right? So anyway, these videos are to help you. I'll be doing them from time to time when I have a chance. I know it's a long video. Obviously, I want to make sure that it's thorough. So my goal is to make a thorough video to help you out. I could make a really good video or I could make a short video, and I chose to make a really good video. You watch the parts that are necessary for you. If you don't need any help on that part, you can always fast forward and things like that, all right? Anyway, I wish you the very best. Thanks again for watching the video, and I hope it's helped, and have a wonderful, wonderful, wonderful day. As always, I am super proud of you for taking the time to better yourself in your math skills. Thank you, and have a great day.